Welcome back, Pre-Calc Excel students. Today we're going to cover section 10.8 on graphs of polar equations. So in the previous section you learned how to convert coordinates, you learned how to convert equations. Now you're going to learn how to plot the graphs of polar equations. So let's first talk about symmetry. If replacing r theta with r and pi minus theta, or negative r negative theta yields the same equation, then the graph has symmetry with the line theta equals pi over 2, which remember is the vertical line. If replacing r theta with r negative theta or negative r pi minus theta yields the same equation, then it has symmetry with the polar axis, which is the horizontal axis. And if replacing r theta with r pi plus theta or negative r theta yields the same equation, then the graph has symmetry with the pole. So I don't memorize all of this stuff, but I do keep this in mind, the quick test for symmetry. If the graph is in the form r is equal to f of sine theta, then it's symmetric with respect to the line theta equals pi over 2, which should make sense from what we've talked about in the past. The sine of theta, it depends upon y. The sine of theta is the same as the sine of pi minus theta. So you have those same values, which gives you that same y value over the vertical. You have that symmetry. If the graph is in the form r is equal to g of cosine theta, then it has symmetry with respect to the polar axis, which again, from what we've talked about in the past, the cosine of theta depends upon x, and that would be the same as the cosine of negative theta. So when the cosine of theta is equal to the cosine of negative theta, you have that symmetry over the horizontal. So that's what I keep in mind, is when I see sine theta, I think symmetry over theta equals pi over 2, cosine theta, symmetry over the polar axis. The maximum values of r, they depend upon theta, and that's going to change from equation to equation. So you just have to think about what will give you the maximum r value, and you could solve it. We'll get to that when we do some graphing. But that will change, and again, it's dependent upon theta, it's dependent upon the trig function. The zeros, they occur where r is equal to 0. So we'll look at that as well as we're doing our sketches. Okay, some special polar graphs. So we have the limisones, which have the form r is equal to a plus or minus b cosine theta, or r is equal to a plus or minus b sine theta. So when I look at these, I can tell these would all be of which form. Which of these do you think? If you said cosine theta, you're correct because they all have that symmetry over the polar axis. If it were of the form sine theta, then you'd see the symmetry over the line theta equals pi over 2. Rose curves. Okay, so we have n petals when n is odd, and 2 n petals when n is even. So here's the form r is equal to a cosine n theta. Okay, so n is 3, we've got 3 petals. Here, n is 4, we've got 8 petals. And again, notice that symmetry over the polar axis. When it's a sine theta, or sine n theta, here n is 5, we've got 5 petals. Here n is 2, we've got 4 petals. And again, notice the symmetry over the line theta equals pi over 2. Circles and lemniscates. So here we have our circles, okay, a cosine theta or a sine theta. And again, you'll see that symmetry either over the polar axis or the line theta equals pi over 2. The lemniscate has the form r squared is equal to a squared sine 2 theta. Kind of looks like our infinity symbol. And notice this one has symmetry with the pole. Okay, and there's that distance of A. Okay, so whatever this number is, you would take the square root, and that gives you the distance across the loop. For this one, this is cosine 2 theta, and again, you have symmetry this time with the pole and with both axes, the polar axis and the line theta equals pi over 2. So let's get on with our first sketch. Sketch the graph of r is equal to -4 sine theta. So when I see this form, and this is going to take a while until you get used to them, but I know right off the bat when I see sine theta, I'm going to have that symmetry over the vertical. But hopefully you'll start to pick up on, it's not easy to remember all of them, but I do remember the circles the best. Anything that has the form a cosine theta or a sine theta is going to end up being a circle. So I started plotting some points. We always plug in theta and solve for r. So when theta is 0, the sine of theta is 0. So that gives me 0. For pi over 6, the sine of pi over 6 is a half. So I get -2. For pi over 4, that's root 2 over 2. So it's -2 root 2. Pi over 3 is root 3 over 2, so that would be -3 root 2. The sine of pi over 2 is 1, so that gives me -4. 2 pi over 3, the sine of 2 pi over 3 is the same as pi over 3. So that's going to give me -3 root 2 again. Okay, so I want to stop for a second and actually plot some of these points and show you. So we've got that point at the pole, 0, 0. Then we're going 2 to the left, and we're rotating pi over 6. So that's this point here. Then -2 root 2, so root 2 is 1.41 roughly, so that's about -2.8. So I'm almost going to 3, and then I'm rotating pi over 4. And then, oops, I wrote this backwards. Oop. I don't know if I said it backwards, but this should be -2 root 3. The square root of 3 is about 1.73. And if I multiply that by 2, I get about 3.5. Okay, so I'm going 1, 2, 3.5 out and rotating 2 pi over 3. And then, let's see, where am I? Pi over 2 and -4. So we're going -4 and rotating to pi over 2. Okay. So far I have these points. Now I want to continue on in order. So if I continue on, what did I do? Oh my gosh, I wrote this one backwards too. Whoo! Sorry guys. At least I'm catching my mistakes here. You don't have to send me an email or anything. Okay, so let me just double check that. So the sine of 2 pi over 3 is root 3 over 2. So it's -2 root 3. Okay. All right. So -2 root 3. So we're back to the -3.5 roughly. So I'm going negative almost, see, 1, 2, 3.5, and then rotating 2 pi over 3, which brings me to here. So you can see now I'm going to get points that are symmetrical with the ones that I already have, symmetrical over that line, theta equals pi over 2. So 3 pi over 4, that's the same as the sine of pi over 4, so that's negative 2 root 2, or negative 2.8. So I'm going negative 2.8 out and rotating to here. So this is the point that's symmetrical with this one. And then 5 pi over 6 is the same as pi over 6. It's a half, right? The sine of 5 pi over 6 is a half, so this is negative 2. And then the sine of pi is 0, so it becomes 0. So I'm going negative 2 and then rotating 5 pi over 6. And that gives me this point here, which is symmetrical with that one. So I wrote these out. I mean, once you pick up on the fact that you have the symmetry, you could start flipping your points over the axis. But I always like to test some extra values to see if I have the full graph or not. Okay, so do you see what we have here? Whoop, let me make that clear. We have a circle, which we expected. And then I'm going to show you, I did a little bit of work to get the rectangular form, which you now know how to do. So you could also do that as well. There we go. So over here, I took this equation, I multiplied both sides by r, so I get r squared is equal to negative 4r sine theta. And then I did the substitution for r squared, x squared plus y squared, and I replaced r sine theta with y. So I added the 4y to the other side, completed the square, right, taking half of 4 and squaring it, adding that to both sides, and then I put this trinomial in factored form, and there's the equation of my circle. So this would be the circle with the center at 0, negative 2. And the radius, and this is r squared, so the radius is 2. So there's that center, and there's that radius of the length of 2 units. Okay, so when you recognize it, you can always check and see if it makes sense, if your sketch makes sense by looking at the rectangular equation. Okay, our next example is r is equal to 3 plus 2 cosine theta. So what kind of symmetry are we expecting here? If you said polar axis symmetry, that's correct. So this one, I put some points in advance. If we start with theta equal to 0, the cosine of 0 is 1, and that's going to give us our maximum. The maximum that we were talking about. When I see an equation like this, my maximum is going to be when the cosine of theta is 1, and that occurs at 0, okay, and that gives me that radius of 5. So for pi over 6, I already calculated the decimals and got these decimals. Pi over 4, pi over 3, the cosine's a half, and so I'm adding 1 to 3. Pi over 2, the cosine of pi over 2 is 0. 2 pi over 3, now it's negative 1/2, so I'm subtracting 2, or subtracting 1, which gives me 2, and so on. Okay, until we get to pi, the cosine of pi is negative 1, so I'm subtracting 2, and that gives me 1. So when I plot these points, now I have positive 5, 0, so that's out here. Let's see, 4.73 for pi over 6, 4.14 for pi over 4. At pi over 3, I'm right at 4. Pi over 2, I'm at 3. at 2 pi over 3, I'm at 2. And then 3 pi over 4, 1.58. 5 pi over 6, I'm just past 1, 1.25. If I make that a little bit closer. And then at pi, I'm at 1. Okay, now from there, I'm going to use the symmetry that I know I have, and that's why you want to keep that symmetry idea in your mind. It saves you from plotting extra points, or from calculating extra points. So now I know I have this point here. Okay, it's 7 pi over 6 would be the same as 5 pi over 6. And then I have this point at 5 pi over 4. And then, let's see, here I was out at 2. So 4 pi over 3, I'm out at 2. And then I'm at 3. And again, flipping this point over the axis. And then I'm at 4. And then just beyond 4. And then almost to 5. And then back to 5. Okay, so if I were to sketch this, do you see the shape? And again, once you learn these patterns, if it's 3 plus or minus 2 cosine theta, right? Remember that form? Let's see, here it is. My box is in the way. 3 plus or minus 4 cosine theta, or 2 cosine theta, we get that shape of the limosome. So I'm going to cheat and show you the graph on Desmos, because I know I can't do a good job sketching out that curve with my pen. You know how good I am with curves. Okay, so there's that limosome, which I'm not really sure, but I'm assuming, I don't know, I see the word lima in there, kind of like a lima bean. But there are all the different types of limosomes. Going back. And you can have one with the loop, okay, when the ratio of A over B is less than 1. So you can see how it changes depending upon that ratio of A over B. Okay, so now the next one, why don't you try this, pause the video, plot some points, think about the type of symmetry that you're going to have, and when you're done, come back and we'll compare graphs. Okay, so hopefully you got another limosome. This is the one with the loop. Okay, if we look at that ratio, whoops, wrong way. Okay, A over B less than 1. That gives you the loop. Okay, the next one, 5 times 1 minus cosine theta. So go ahead and try this one. When you're done, come back and we'll compare sketches again. Okay, let's see. Okay, another limosome. And see how it has that symmetry with the polar axis. Okay, and for the maximum R value, that would occur in this case when cosine theta is -1, right? Because that gives us 2 times the 5, which is 10. So the cosine of theta is -1 out at pi, and there's that max R value of 10. Okay, I've got one more for you. This one you can try on your calculator. So if you haven't changed your calculator's mode yet, you want to change it to polar mode. And that's the same spot as when you changed it to parametric. So change your mode Make sure you're in radian measure to match your window. Then when you go to your y equals button, it should say r equals. And when you hit your key for your variable, that xt theta, you probably always wondered why is it x and t and theta. So t appears when you're in parametric mode and theta will appear when you're in polar mode. So go ahead and enter these into the calculator and you'll see one of my favorite objects that I like finding on the beach. Okay, let's see. There you go. The sand dollar. At least I think it looks like one. So I hope you enjoyed this lesson. I hope you have a lot of fun with these graphs. There's a lot of cool different types of things that I'm sure you've never graphed before. So have some fun with this. And if you have any questions, remember you can always join me on Zoom any day of the week from 11 to noon. Have a good day.